in figure 9.7, that's this figure in the upper left hand corner here, the book does a really good job of explaining the different kinds of acidity that are possible in the soil. So far, when we've talked about measuring acidity, really what we're talking about is measuring this acidity right over here. So this active acidity. So when we put a pH probe, or when we have a pH strip that we use to test the soil, really what we're testing is are the acidic ions, the hydrogen ions, really out here beyond the area where CEC is really active. But we do obviously have hydrogen and aluminum occurring at and near the CEC sites. So you can see here all around this the edges and some of the interlayer spaces here in the clay, we've got aluminum and hydrogen that are there. We also have this exchangeable. This is really where we think about the exchangeable portion of ions existing. These ones that are attached over here are attached a little more long term. It's not that they don't come off, but when we think about the exchangeable portion of acidity, this is what we're thinking about in here. And there's still attraction in this area. So again, if these are negatively charged colloids, they do attract and attach these ions out here. But they're also active. This negative charge is also active beyond just these edges. So these ions that are here also are attracted because of that negative charge. So we have an acidity that exists here. This is called residual acidity. We have acidity that exists near the surface but not directly on the surface. That's exchangeable acidity. And then we have active acidity beyond the scope of these negatively charged colloids, and they're all important pieces of the puzzle of soil pH and how it changes, and how it is that we actually add things like lime to the soil to get changes in the soil. I want to bring forward this. This is also just below figure. This is figure 9.8, so just below figure 9.7 in your book. And this is a good example of basically we're looking at one type of soil here that goes through some processes. This soil has a large amount of exchange and residual acidity. So this particular soil, probably has a very high CEC, and there's a lot of acidic cations on that, and there's quite a few acidic cations on the exchangeable part of the CEC. So with something like that, with a soil like that, you can think about that as kind of a coffee dispenser you may have seen at a social function or a breakfast or something like that. And that is, you can, if the pot is very large, it's holding a lot of coffee, and you can walk up to it and you can open that spigot and get a nice sized cup of coffee, and it doesn't really affect the overall large capacity very much. In fact, you can see here that the level, what is originally here, is drawn down, and then it rises back up because there's plenty of coffee in this particular container. So it doesn't appear that if you were just looking at it from the outside and you got a cup of coffee out of it, and then you see that little, there's that little watch glass right in here, and you see it go down, and then it goes right back up. It gets refilled, so that you can know the level of coffee there. This this portion that's in this tube here, we can think of as the active acidity. Okay, so that looks and corresponds to this kind of acidity here. And when we take hydrogens away, so let's say we took we consumed these somehow through one of those processes, we took it away, you would find that that the exchangeable acidity here actually will replace those acidic cations in there. And if we have a really large CEC, then we'll replace what was in the exchangeable acidity. And it's going to look like there wasn't that much change. And this is what we call the capacity of a soil to buffer itself, to protect itself against changes. So a large CEC, so if we have a large CEC in the soil, then you can take some of that acidity away. You can consume some of those hydrogen ions and take them somewhere else, and this active acidity is just going to fill itself back up again. Okay, because we have a lot of acidity that we can replace that active acidity with. Okay, so that's how a high CEC. This is why CEC is also important to pH, not just the fact that we can hold nutrients on them. It's also important because if we have a high CEC and we have a high amount of hydrogen on that CEC or aluminum on that CEC, it's going to be a long time before we get rid of all the active acidity ions right here, because it's filled from this big pool of CEC. On the other hand, this is one over here with a low CEC. It doesn't have very much capacity to hold hydrogen ions. So once you start taking 2, 3, 4 glasses away, okay, of coffee or hydrogen, this is going to start lowering, and it's going to get lower, and it's going to get lower much more rapidly than the one with high CEC. So low CEC, the amount of CEC, or we could say the higher the CEC, typically the higher buffering capacity. I'll just abbreviate that. The higher CEC, the higher the buffering capacity of a soil. And that's a real important factor in a lot of the world where we have low pH soils that are affected by low pH, that might be very difficult to grow crops in. We have to figure out how it is that we take care of this much CEC or that much acidity if we have a soil that may have some kind of higher buffering capacity or have a buffering capacity, and how do we take care of those kinds of things, of that kind of soil with a high buffering capacity, but we need it to have a higher pH than it does, and we have to raise the pH, so we have to consume the active acidity. We've got to get this stuff, and we've got to start chipping away at this stuff here and this stuff here.